Hello people, today we're going to do something super fun that is called graphical derivatives. This is something that a lot of people have trouble with, so I decided to do a lesson. So the way that this is going to be is that I'm going to draw a graph of a derivative, and then I'm going to explain everything from there. And that's all I'm gonna do because it takes time to understand. Okay, so I'm gonna draw my axis. So on your paper, do exactly the same thing that I'm doing. Okay, I'm gonna ask you guys to write everything exactly on the same spot that I'm writing. Okay, so so next I went from 1 to 3 and from -1 to -3. Notice that I'm not writing numbers on the y-axis because the numbers on the y-axis are not important in this specific uh, point, in this specific problem. Okay, so I'm gonna try to do it as cool as possible. Okay, so this is our function. So this is actually the derivative of the function. Okay, notice the prime. So this is f prime. Okay, okay, now on this side, this is node number 1. I have when, can you guys see? Yeah, when f prime is negative, it means f of x is decreasing. Okay, cool. So we're gonna leave it at that. I'm gonna come back and explain it. Let's see, should I do it like that? Okay, yeah, let's write the whole thing and then I'm going to explain. Okay, number 2, I have it right here on the bottom. I have f prime changes from negative to positive, like this. If you remember, negative to positive, that means, I'm gonna say it means f of x has a mean. This happens right there, right here. Okay, that's number 2. Okay, number 3, I put it right here at the top. From -1 to 1, from -1 to 1, comma, f prime of x is positive. It means f of x is increasing. From -1 to 1. Okay? This is this part right here. Okay? Remember, I'm gonna explain it in a little bit. What I wanna do first is I want us to write everything, all my notes that I have. Number 4 right here. I have f prime of x changes f prime of x changes from plus positive to negative. So positive to negative. So f of x is a max. So f of x has a max. Has a max. Okay. This happens at 1. Remember, I need you guys to copy it exactly how I have it. Okay. And then I have a little star right here. So you know how my notes, I just do stars. So I have when f prime of x crosses or touches the x-axis, comma, it means that the slope of f of x, that the slope of f of x is equal to 0. Okay, the slope is equal to 0, or the same thing as a horizontal tangent. A horizontal tangent. Okay, and then I have a little drawing that looks like this. That would be the horizontal tangent. Cool. And the last thing I have, let me close this so we don't get confused. And then number 5, I have it right here below. When f prime is negative, when f prime is negative, it means f of x, can you guys see? Yeah, is decreasing. Okay, so here we go. So what I'm going to do, I'm going to explain number 1. I'm going to explain the whole thing right now. So the first one we have, let me move this. I'm going to explain number 1. So number 1 says, when f prime of x is negative, it means f of x is decreasing. Okay, so let me explain again. The title is Graphical Derivatives. If you see, when you take the AP exam or in your calculus class, you will see that they give you the graph of the derivative. Even the problem is gonna say, when they give you the drawing of the graph, it's gonna say f prime at the top, and the problem is gonna say the derivative of f of x is given. So they tell you like 3 times that this is the derivative, so you don't make a mistake. Okay, so number 1, it says when f prime of x is negative, it means f of x is decreasing. Okay, so this is where some people have problems understanding. Okay, this is y equals 0, right? You agree? So this is y equals 0. This here are the positive numbers, and this here would be the negative numbers. Okay? So basically, what we're saying here, when f prime of x is negative, we're saying, you see your graph, your line, this is the derivative. Here is the derivative negative? Yes, because it's below 0. Okay? So this is 0 right here. This is 0. Your line is below 0. That means all this is negative. Okay? Again, we are not talking about the slope of the line. That's not what we're talking about. We're actually talking about the points. If you plot a point here, the y coordinate, is it positive or is it negative? Well, it's below 0. Therefore, here is negative. That's what this means. Okay? So f prime is negative right here. Okay? And that's the same thing that we put on number 5. If you can see number 5, when f prime is negative, it means f of x is decreasing. I haven't talked about f of x is decreasing. I'm just explaining this. F prime of x is negative. So if you look at our graph, f prime of x is negative here and here. Okay? Again, we're not looking at the line going up, the line coming down. No, the only thing we're looking at is, where is your line? Is it on the positive half at the top, or is it on the negative half on the bottom? See here, this is on the negative half, so that means that this line is negative. Okay? So that's what this, remember, this is f prime, so that means that this is negative right here. Okay? Now, what does that mean? When you're about to graph f of x, that means that f of x is decreasing. Decreasing. Okay? Let's leave it at that. So that's number 1. Number 2, f prime changes from negative to positive. Okay, let me explain that first. F prime changes from negative to positive. And then I have the arrow that says it happens right at this point. Okay? So we just talked about this line being negative because it's below 0. Okay? Here, this point, the y coordinate is at the 0, right? After this, it becomes positive because it jumps to the top. Okay? So that's why we say it changes from negative to positive at x equals negative 1. Okay? Below y equals 0 is negative, above y equals 0 is positive. Okay? That's all. Now, if you translate it to what it means in f of x in your original function, that actually means that f of x has a minimum. Okay? So whenever you see here that your derivative changes from negative to positive, you have a minimum at x equals negative 1. That's what this means. Okay. Again, if you don't understand, you'll understand a little bit more when I finish this problem. Number 3. From negative 1 to 1, f prime is positive. Let's talk about that. From negative 1 to 1, and remember, all the numbers that we're talking about mean we're only talking about the x, not the y, only the x. From negative 1 to 1, that means from negative 1 to 1 right here, f prime is positive. How do we know? Well, we just said that anything above the line, anything above y equals 0 is positive. So you see how your line is at the top right here? So that means that your function is positive. Okay? So f prime is positive right here. What does that mean in f of x? So f of x would be increasing from negative 1 to 1. Okay? So basically we're talking about two things. The first part of my note number 3 is telling you from negative 1 to 1 your derivative is positive because it's above 0. That's it. Now what does that mean? Oh, it means that your function would actually be increasing from negative 1 to 1. So if you draw a line, the line would from negative 1 to 1 it will be going up. Okay. Number 4, f prime of x changes from positive to negative. So f prime of x changes from positive to negative, and I put the arrow right here that it happens here. So remember, this is positive, positive, then you hit 0, and then what happens? It becomes negative again. Okay, so changes from positive to negative. When the derivative changes from positive to negative, as you remember in our one of our lessons, when the derivative changes from positive to negative or increasing to decreasing, that means that your function has a max right here. Okay, so where does the max happen? At x equals 1. How do we know? This is the derivative. The derivative changes from positive to negative. That's number 4. Okay, what do I have here? Now look, uh, I'm gonna jump to number 5 because number 5 is exactly the same thing as number 1. So when f prime is negative, it means f of x is decreasing. So you see f prime is negative here because it's below 0. So that means that the derivative is negative and our function is decreasing. Okay. Now let's go to the start right here. I have when f prime crosses or touches the x-axis, it means that the slope of f of x is equal to 0. Okay. So when f prime crosses or touches, here we crossed it and here we crossed it. Okay. That means that the slope of f of x is equal to 0 or a horizontal tangent like I have it here. Okay. So you see how this is a max and you can also have a min like that, this being the tangent. Okay. So these things happen when f prime, and this will be for f of x. Okay. So when f prime crosses or touches the x-axis, this happens. Okay. All right. So before we continue, what I'm going to do now is I'm going to draw the actual function f of x. So I'm going to draw it here. I'm going to make it small because I want us to have everything on at the same I don't want to be moving the paper, so I'm going to draw it here kind of small. Okay. Okay. So what I like to do, first I'm going to label it. This is f of x. Let me just do something here so we don't get confused. All right. So you see here how we have 1, 2, and 3, and then negative 1 to negative 3. I'm going to do the same thing here. I'm going to put 1, 2, 3, and then 1, 2, 3. Okay. And then I'm just going to do the 3 little lines here and the 3 little lines here. Again, I'm not putting numbers on y, okay, or on f of x. Now, I always like to start from left to right, as I'm going to do here too. Let me move it a little bit. Okay, so the first thing that happens, we see, is this line here, okay? And I know that the first point, something happens at x equals negative 1, okay? At x equals negative 1. All right, so what's going on? So this is telling me that the derivative is negative. The derivative is negative. So that means that our function is decreasing. When the derivative is negative, that means that the slope is coming down. Okay? So I'm gonna go here. I'm gonna come down. And then I'm just gonna put a dot right here. Okay, so it's coming down, and all of a sudden it stops at 1. So what just happened? Well, I know that this is going on because of this right here. Oh, this is -1, my bad. -1, -2, -3. Okay, at -1, the derivative changes from negative to positive. And remember, based on the note here, when it crosses the x-axis, that means you have a horizontal line. So this would actually be a min. So this is a min right here. How do we know? Because it changes from negative to positive. Negative to positive has a min. Okay. Now, the reason why we made it here all the way to the bottom is so you don't get confused that, wait, but the line is negative right here. No, this is the function. That only happens right here. We're talking about the derivative being negative here because it's below 0. That has nothing to do with this. This is your function. So what we're looking for here, what we're actually looking at is the actual slope. So the slope of the line is negative. You see, the slope of the line is negative. The slope of the line is negative. The slope of the line is negative. It's negative, 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 and then 0. Okay. So I'm done with this. What happens next? Look, the derivative is positive. What does that mean? The slope is positive. So from -1 to 1 is positive. So that means that my f of x is increasing. So at 1, I'm going to put a little dot. I am purposely putting the dot in between this line and this line so you don't get, so you don't want to be like, well, is this 1 or 2 or what? No, just leave it right there. Okay, we only care about -1 and 1 right now. So remember, this is a min, so it starts to go up. Okay, so it starts to go up, and then we don't go straight to 1. We go a little bit around, because what happens at 1? At 1, the derivative changes from positive to negative. So what happens when the derivative changes from positive to negative? When the derivative changes from positive to negative, f of x has a max. Okay? So that means that this is a max right here. Okay? Now we're right here. There's a maximum, we already put it. What's next? After 1, I just see that the derivative is negative. What does that mean? That your line is actually coming down. And that's it. Okay? So I think it's a lot. It's a lot to process, but once you understand it, it becomes a little bit easier. So let me go over it again. And you know the cool thing, what I like to do when I teach this lesson is I focus basically like the first hour of the class. I focus just on this because there's no point of doing other problems if you don't understand what this is all about. Okay, so let me explain a little bit faster. Again, you know you can always pause the video, look at it on your own, or review rewind it or whatever. Remember, this is called graphical derivatives. So basically what they're telling you is, look, we're going to give you the graph of the derivative of f prime. Your job is to graph the function based on the derivative. That's it. Okay? So what I like to do is I do my axis. I look at the points of what's going on. So I know something is going to happen at -1 and at 1 because the derivative crosses. So I'm going to put a point at -1. Well, let's leave it at that because I want to go from left to right. Before -1, I see here that the derivative is negative. How do I know the derivative is negative? Because it's below 0. So below 0, that means that the derivative is negative because all these numbers are negative. Okay, so that's how the derivative is negative. So since the derivative is negative, and it's getting closer and closer to 0 until it reaches 0. So what does that mean? The derivative is negative. That means that your the line, let me do it right here. Okay, so this would be the derivative. Okay, so you know how if the derivative from left to right is coming down, that means the slope of the line is coming down. So the line is actually decreasing, right? It's going down. So that's what a negative derivative does. And then here we know that it reaches 0. So what does that mean on your line? Well, it means that the derivative is 0. It means that it went horizontal. So where does that happen? Oh, at x equals -1. Okay, x equals -1. I know I have a mean because it changes from negative to positive. Okay, so a positive slope, this means you have a positive slope because it's above 0. How does a positive slope look like? Well, it looks like this. It's going up. Okay, it's going up. Then I know that from -1 to 1, because you have a positive slope, that means that my function here is increasing, it's going up. And then I know that something happens. That's why, if you remember, these are called critical points. When you set the derivative equal to 0, that's what this means. So when you're looking for a critical point and we tell you to set the derivative equal to 0, we mean that if you would graph it, the derivative would actually, your line of the derivative would actually hit 0. That's what it means when you set it equal to 0. Okay? And then we say, so when you set it equal to 0, the critical point might be changing from increasing to decreasing, like here, or decreasing to increasing. So negative to positive or positive to negative. So I know if it changes from negative to positive, I know this is a mean, like we have it here. And then I have a positive derivative. That means a positive slope. So I know my line is increasing. And then all of a sudden, at 1, it's not increasing anymore. So at 1 is 0, which is this right here. So that's the slope of 0. And then our derivative goes back to the bottom. So that means that our slope is negative. So our function is coming down because it has a negative slope. Okay? Isn't that awesome? Cool? So derivative is negative here because it's below 0. I just put the negative so you guys can see that anything below 0 is negative. So negative derivative, negative derivative. We're not talking about slope. No, this is the derivative, negative here, positive at the top. This is your function. You have a negative derivative here because the slope is negative. Derivative is equal to 0. And then derivative is positive. Derivative is positive. That means that your function is increasing. Derivative hits 0. And then your function continues to decrease because the derivative is negative. The slope is negative. It goes down. Okay? Now, there's a trick also that can help you. So I'm gonna go here. If you look at our derivative, our f prime looks like this. Doesn't that look like, we don't care right now about what the function is, but our f prime, oops, you guys don't tell me, you can't see. Okay, so our derivative looks like this. Doesn't that look like a negative x squared? Oops, negative x squared. And then we have our function. Let me do, you know what? Let me do the function on this side so we can see it. Our function would be, so think about this. This is the derivative. Remember, when you take the derivative of a function, you subtract 1 from the exponent, right? So if this is x2, if we add 1, we get this one. So f of x would be something like negative x cubed. How does negative x cubed look? Negative x cubed looks like this. Okay, so you see, this is our function. Yeah, obviously you have this, right? But what we're talking about is the endpoint. So the endpoint is coming down here, and then it keeps coming down here. Okay, so that's what we're talking about. But look, this is x cubed. If you take the derivative of x cubed, you get 3x squared. Okay, so we're just looking. So if you have uh, an odd derivative, your function is gonna be even. Okay, look at this one. Let's see. What about if I do, so this is x squared, so let's go back one. So what about if I have f prime of x looks like that? So that's just x. Okay, let me circle this. Okay, so if I have the derivative looks like a line, y equals x. So if I add 1 to this one, then that means that my function would be a square. So my function will look like this. Okay. Now let's look at this one. Look, this is my derivative. So the derivative is negative, 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 negative. And here, at x equals 0, it changes from negative to positive. So when the derivative changes from negative to positive, as you have it right here, negative to positive, you have a mean, f of x. Do you see here? You have the mean. Okay, so when the derivative changes from negative to positive, you have a mean. Again, the derivative is negative, that means that your function is decreasing. You see how your function is coming down? The function is decreasing, the function has a mean. Oops, the function is decreasing, the function has a mean. What happens next? Well, the derivative is positive. Positive derivative, can you guys see here? Well, you guys have it, but let me show you. Positive derivative, oh wait, where is it? Right here. When the derivative is positive, it means f of x is increasing. So our derivative is positive, f of x is increasing. Okay? Now let's look at this one. Derivative, so I have a point here, and I have a point here. Okay, so derivative is negative, 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 and then something happens here. So this would actually be something like this. Just like the other one. Okay, forget about this line. This line doesn't exist. So you guys can see it. Okay, so the derivative is negative, and all of a sudden at this number, which would be this one, you have a change. So it changes from negative to positive. Okay, so negative means that your function is decreasing. So you see your function decreasing here, decreasing, decreasing, and then the derivative hits 0 right here. So from negative to positive, that means you have a mean right here. And then what? Well, you have a positive, 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 and then you hit 0 again. So that means that your derivative is increasing, I'm sorry, your f of x is increasing, and then here you hit a max, okay? Because you got your derivative change from positive to negative, okay? So what does that mean? You are increasing, 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 you got to the derivative equal to 0, and then the derivative is decreasing. That means that the slope is negative. So when the slope is negative, or the derivative is negative, that means that your function is decreasing, and that's how you know you're going down. Cool? Is that awesome or what? Okay, at this point the video is 35 minutes. Okay, so what I need you guys to do, I need you guys to go back to the beginning of the video, make sure that you copy everything correctly, or even if you don't want to watch the video, you can study it on your own. So this is the way that I will study it. So I will go to number 1. So forget about everything else. So just look at number 1. So number 1 says when f prime, this is f prime, this line, is negative. What does that mean? Okay, so before that, when f prime is negative, well, what does that mean f prime is negative? That means that your line here is below 0. That's what f prime negative means. Your line is below 0. Okay? Now, when you translate it to your function, that means that your function is decreasing. So basically from negative infinity, negative infinity is on this side right here. So from negative infinity, your function is decreasing until it hits 0 on the slope. So the derivative is negative and you hit 0. That means that your function is decreasing and then you get to a min because your derivative changed from a negative to a positive. And then when the derivative changes from negative to positive, you have a min. Okay, that's number 1. Again, number 2, f prime changes from negative to positive, that's a min. We just did that, you see? Now we got 1 and 2 out of the way. Number 3, from 1 to 1, f prime is positive, that means that your function is increasing. I know that my derivative is positive because it's above 0. This is positive, okay? What does that mean? What does that translate in my function, in my f of x? That means that my function is going up, okay? All of a sudden, your derivative is not positive anymore. You hit 0, and then it changes to negative. When the derivative changes from positive to negative, you get a max, okay? What's next? You got a negative derivative. That means that your function is decreasing, okay? That's it. That's all I'm gonna do. Let me see if I have something else that I can do, that we can do. No, I think that's it. So we're gonna, on Monday, we're gonna do another example of this. I'm expecting everyone on Monday to know this by heart. Okay? Alright, that's it, guys. Peace.